Hi guys, welcome back. In today's video, we're going to look at inverse variation, also known as inverse proportion. Now, in our last video, we looked at direct variation. If you have not watched that video as yet, please see the link above. In our last video, we looked at direct variation. Now, with direct variation, if we have two quantities, when one quantity increases, the other quantity will also increase. However, with inverse variation, it's the complete opposite. If we have two quantities, one quantity increases and the other decreases. Also, if one should decrease, then the other would increase. And that's basically to the point of what inverse variation is. I provided you with some graphs of what inverse proportion graph or inverse variation can look like. Simply put, as one quantity increases, the other decreases. Now, just like direct variation, the steps are the same. You're going to write the statement using your proportionality symbol, then write your equation using your constant of proportionality. Then you're going to use the information to find your constant k or whatever variable it is, and you're going to find a new equation that you can use to find other unknown values. So if you are a notes person, please make your notes as we start our practice questions. Write off the steps if you need to, because you may need them when we are practicing. In our first practice question, it reads, y is inversely proportional to x, and y is 6 when x is equal to 5. Calculate a formula linking x and y and use it to find the value of x when y is 15. So our first step, let's establish, it says y is inversely proportional to x. Now we can write that easily. Y is inversely proportional to x. And that's going to be 1 over x because it's inverse proportion. Inverse proportion, so we are reciprocating. Hence, the equation is going to be y is equal to k times 1 over x. Y is equal to k over x. So, we have a equation linking x and y. So we now need to find the constant k. So when y is 6, x is 5. So let's plug in what we know. So anywhere I see y, I'm going to substitute for 6. And anywhere I see x, I'm going to substitute it for 5. So therefore, k is equal to 30. So our equation is, or the equation linking x and y is y is equal to 30, and that 30 is our constant of proportionality over x. And we have found the equation linking x and y. Then it says to find the value of x when y is 15. So find x when y is equal to 15. So our equation again, y is equal to 30 over x, because we now use our new equation that we have found here. Hence, it says y is equal to 15, so 15 is equal to 30 over x. Want to solve for x, so we can apply cross multiplication. So you can say 15 over 1, the same thing as 15. For those who may need the complete breakdown, cross multiply. So we have 15 times x is equal to 30 times 1. So we have 15x is equal to 30. To find the value of our x, we're going to divide both sides by 15. So x is equal to 2. So the value of x when y is 15 is 2. Alright, so in our next question, it says the quantity y varies inversely as x minus 2 all square, and y is 1 when x is equal to 5. A. Find the formula for y in terms of x. B. Find the value of y when x is equal to 4. And C. Find the value of x when y is equal to 9. There's a slight grammar error here. Could just ignore it for me. Y in terms of... Yeah, could just ignore that grammar for now. So alright, let's work it out. So we have y varies. Inverse proportion. So inversely means it's by the reciprocal. So x minus 2 all square. Now we're going to write our equation with our constant of variation. So y is equal to k multiplied by 1 minus x minus 2 all square. So this can be simplified to y is equal to k over x minus 2 all square. So now we have our equation with our constant of proportionality, and we now need to calculate what our constant of proportionality is or our constant of variation. So hence, let's find k. So we use our two known values when y is 1, x is equal to 5. Hence, anywhere I see y, I'm going to substitute it for 1. And anywhere I see x, I'm going to substitute it for 5. Stuttering almost came on. So we have 5 minus 2 square. So hence, we have 1 is equal to k over, and 5 minus 2 is 3, so 3 square, which is 9. So 1 is equal to k over 9. Hence, we can know that by applying cross multiplication, 1 times 9 is 9, 1 times k is k. So therefore, the formula for y in terms of x is y equal to 9 over x minus 2 all square. So that's our formula. So we have found part A. Now part B now is asking us to find the value of y when x is 4. So using the same formula, y is equal to 9. Anywhere I see x, I'm going to put 4. So we now have 4 minus 2 all square. So y is equal to 9 over 2 square. So we have 9 over 2 square, and we know that 2 square is equal to 4. So we have 9 over 4. Y is equal to 9 over 4. And 9 over 4 as a decimal is 2.25. So the value of y when x is 4 is 2.25. Now part C is asking us to find the value of x when y is equal to 9. So using our same formula, I'm just rewriting it. Anywhere I see y, I'm now going to put 9. So I have 9 is equal to 9 over x minus 2 all square. So we now have to expand our x minus 2 all square. We could expand, but we don't have to expand, because the expand might end up into something very long and cumbersome. So just easily continue cross multiplication. So we have 9 times x minus 2 all square is equal to 1 times 9 give us 9. So realize that we have 9 on both sides, so we can divide both sides by 9. So we want to move this 9 from here, so 9 to itself 1, 9 to itself 1. So we have x minus 2 all square is equal to 1. Let me just clean up right here, take this one out of the space, so that we don't have any problem. Let me just clean up right here a bit. Alright, this is the one here, so we have x minus 2 all square is equal to 1. Now we're going to solve for x, so we get rid of the square by taking the square root of both sides. And we know that square root is plus and minus, so whatever we get plus and minus 1, and we're left with x minus 2 is equal to plus and minus 1. So x is equal to 2 plus and minus 1, where our values could give us x is equal to 2 plus 1, or x is equal to 2 minus 1. So that would give us 3 or 1. So find the value of x when y is equal to 9. The values could be, or the values are 3 or 1. Alright, our next practice question. Two variables x and y are related such that y varies inversely as the square of x. So the square of x, sometimes I like to write before we finish out the entire question. So y varies inversely as the square of x. Alright. So y have a small table here, xy 3, 2, 1.8 r, and x is f, y is 8. Alright, so write an equation in x, y, and k to describe the inverse variation where k is the constant of variation, and b, use the information in the table to calculate the value of k, the constant of variation, r, and f. So we have been doing it all along. So y is equal to k multiplied by 1 over x squared. Y is equal to k over x squared. So that's our part A. Part B1 now asks us to use the information in the table to calculate our constant of variation or constant of proportionality. Same thing. So we can now use a known set. We have a known pair. We always have a known pair. So when x is 3, y is 2. So anywhere in the equation, y is equal to k over x squared. Anywhere I see y, I'm going to put 2, substitute it for 2. And anywhere I see x, I'm going to substitute it for 3. Alright, so 2 is equal to k over 9. Hence, k is equal to 18 because we multiply both sides by 9. Or I have 18 is equal to 18. It's k that is equal to 18. Alright. So k is equal to 8. So we have found our k. So we know our equation that we're working with is y equals to 18 over x squared. So now we want to find the value of r and f. So we can find r when x is equal to 1.8. So anywhere I see x, I'm going to substitute it for 1.8. So y is equal to 18 divided by 1.8 all squared. Plug that into our calculator. And that gives us 5.5. Let me just double check. And don't mind the dogs barking in the background. It's regular. So it's 5.5, and that continues. So that would be our B part 2. And B part 3 now says to find the value of f. So to find the value of f, we're given y. So anywhere I see y in the equation, y is equal to 18 over x squared. So sometimes I just rewrite it for emphasis. So anywhere in this case now we're trying to find f. Whenever x is equal to f and y is equal to 8. So anywhere I see y, I'm going to substitute it for 8 is equal to 18 over x squared. We're going to do our cross multiplication. So we have 8x squared is equal to 18. So we can now divide both sides by 8. So x squared is equal to 18 divided by 8, which gives us 9 over 4. And to get rid of the square, we're going to find the square root of both sides. Now square root is plus and minus. So x is equal to the square root of 9 is 3. The square root of 4 is 2. So it's plus and minus 3 over 2. So the value of our f is equal to plus and minus 3 over 2. Now for the final question in this video. 7 men can dig a trench in 5 hours. How long will it take 3 men to dig the same trench? Now, what we can do, we can draw the table to help us just see the data a bit clearer. So we have, can say workers or men or site man as Jamaican as a construction man builder. So we can just call them workers. And we have the hours. So we know that 7 men can dig the trench in 5 hours. Now, how long will it take 3 workers? Now, common sense would dictate that, alright, if it takes 7 man 5 hours, so 3 man go take them more time. So because they're going to take them more here, more than the 5, you realize that we have a sort of inverse variation in terms of this decreases but this increases. Seen that? So when the number of workers decrease, the time is going to increase. So we realize that this is inverse variation. So we can have some variables. So we can say let A or X or Y, whatever you want to use, element P, Q, R, S, alpha, beta, gamma. Let A be the number of workers. Alright. Let B be the number of hours. Let me just write this properly so that we can know what we're doing. Because I write beautiful. Alright, so the number of workers and the number of hours. Alright, now because it's an inverse variation, because we say as the workers decrease, common sense will dictate that the amount of time taken is going to increase. So once we have opposite things happening with both variables, we know that it is inverse proportion. Hence, we can say that B is inversely proportional to A. So that's going to be 1 over A. So hence our equation is going to be B is equal to K times 1 over A. So B is equal to K over A. So we find our equation in terms of K. Hence, we can go ahead now and solve for K. So anywhere we have our known pair, we have our 7 and our 5. So we know that workers is our A and hours is our B. Just put these in to help us remember. So anywhere in the equation I see B, I'm going to put 5. So 5 is equal to K over 7. So let's find K. K is equal to 35. So 35 is equal to K. K equal to 35. So hence our new equation is going to be B is equal to 35 over A. So now we can find our B when A is equal to 3. So therefore, when A is equal to 3, B is equal to 35 over 3. So B is equal to 11 and 2/3 hours. So therefore it's going to take 3 men 11 and 2/3 hours to complete the same trench. Thank you for watching. Send me an email if you have questions that you would want me to work. See you in our next video.